All right, here we go. This is what we're looking at for today, and finding the inverse functions and also talking about the domain and range. So first of all, this is my original function and it is a line. So my domain is going to be negative infinity to infinity. My range is going to be also negative infinity to infinity. Okay. Now, if I want to find my function, we're going to switch out x equals 4y plus 5. And now go ahead and solve for y. Yep, you're going to do it. I'm waiting. Get y by itself. And verify that I have x minus 5 divided by 4 is going to be y. So I'll rewrite f minus 1, which is the inverse, is going to be x minus 5 divided by 4. Okay? How can we check? Well, we can check and we can put in a number. I don't know. Let's go with f of 3 is equal to, let's go with, I think that's 12 plus 5. So I think we're going to get 17. So what we're going to do is we'll check f of minus 1 of 17. So I'm going to get 17 minus 5 over 4, which is 12 divided by 4, which is in fact 3. So the ordered pair from this guy was 3 comma 17. The ordered pair from the inverse was 17 comma 3. So you know that you have the inverse. Now, as far as the domain and range of your inverse, okay, I'm going to rewrite f minus 1 of x is equal to x minus 5 over 4. Okay, since we're like switching x's and y's, here it doesn't make a difference. But when you have your domain and range for your inverse, those will also switch. So it becomes more important when you get to a problem like B and when you get to, especially get to C. So here, my domain would still be negative infinity to infinity, and my range would also be negative infinity to infinity. Okay, so let's go to this guy right here, the second one. This second one is a parabola, and notice it's giving us a restriction. A parabola is not one-to-one, so as soon as you see a parabola for your original, okay, is not one-to-one, so there are restrictions on the domain. Okay, if we graph this guy real quick, and you could put a real graph if you want. I'm just going to put this. I know that my vertex is at negative 1 comma 5, and I'm facing down. So here's negative 1, 1, 2, 3, 4, 5. Okay, so they're saying that x's are only going to be less than or equal to negative 1. So I'm looking at just this half of the parabola. So the domain for my f of x would be negative infinity to negative 1, and I'm going to include that. And then my range is negative infinity up to, I'm going up to 5 because that's my vertex. Okay. Now, if we go and get that one-to-one function, or I'm sorry, if we go, now we have the one-to-one function and we go and get the inverse, we're going to do the exact same thing. So I'm going to switch x's and y's. So x equals the opposite of y plus 1 quantity squared plus 5. And I have to go solve for y. So first thing, I'm going to move that 5 over, and I'm left with negative, and then I've got y plus 1 quantity squared. And now if I divide everything by a negative, that's going to give me negative x plus 5 over here. So if I'm dividing by -1, divide everything by -1, this becomes positive 5 minus x is equal to y plus 1 quantity squared. Okay, undo the square, which is going to be square root on both sides. And remember, we are going to get that plus or minus square root of 5 minus x is equal to y plus 1. Okay. Then last but not least, I'll move that 1 over, but I've got to figure out which side do I want. So plus or minus square root of 5 minus x is equal, not equal, hold on. I'm going to do -1. And that's going to be equal to y. Okay. So now what I need to recognize is that I've got positive, negative. I've got to figure out which side do I want. Well, the easiest thing to do is to plug in a point. Okay. This next point would be -2, 4. Okay, how do I know? Because I know how parabolas work, right? Over 1, down 1. So I'm going to get -2, 4. So I need to make sure that what's on f to the -1, that better have the parabola 4, -2. Well, I better go plug in 4. So I'm going to have plus or minus square root of 5 minus 4. And then I've got -1 equals y. So in order for me, so now I have plus or minus the square root of 1 minus 1. Do I want -1 or +1? I really want the negative portion of this, so that I would get -2 is equal to y on my inverse, okay? And I don't know why I have a comma there, but it should be equal to y. So I need that negative. So I know that my possibility is, or my inverse is going to be negative square root of 5 minus x minus 1 is outside the square root, okay? Now, I'm going to shrink this up a little so that I have a little bit more room, okay? So I'm going to just move him over here, take this, and go through. Okay, now, domain and range. So since I swapped over, if you go and look over here, you did your domain and range for the original, then I know that this guy, domain, is now going to be -infinity up to 5. And my range is now going to be -infinity up to -1. Okay. So what happened is that these two domain and ranges right here from the original are going to trade because we traded x and y, okay? So the domain became the range, range became the domain, and we call it a day, okay? Let's go to this last one. Last one here. I have, first of all, domain. I mean, we could graph this, but there should be one number that should be glaringly obvious that we cannot have. So we're going to have negative infinity up to 5, union 5 to infinity. Where am I getting this from? Because I cannot have 5. That would make the denominator 0. Okay. Now, range. Friends, this is where last chapter comes in. The range. Where is my horizontal asymptote here? If you had to graph this from last chapter, my horizontal asymptote would be at y equals 1. My end behavior isn't going away. So I have negative infinity up to 1, union 1 to infinity. Okay, you can graph it if you want to check. So now if I want to go and find my inverse, swap out x's and y's. So I've got y plus 4 over y minus 5. Okay, looks like it's a little crazy, but have no fear. We can cross multiply and solve. So I've got x times y minus 5 equals y plus 4. The whole goal is to get all the y's on the left-hand side. That's the goal. Okay. Right now, subtracting 4 isn't necessarily helpful. Yes, I get y by itself over here, but on this side, I still have some kind of multiplication happening. So it makes more sense to go ahead and distribute that x. So I've got xy minus 5x is equal to y plus 4. Everybody that has a y should go to the left. Anybody who doesn't have a y, kick them out and get to the right. So these guys are going to trade places. So he's going to go this way, and this guy's going to go over here. So I'll end up with xy minus y is equal to 5x plus 4. And on this other side, I can now factor out a y. So if I factor out a y, GCF, I'm going to get x minus 1 is equal to 5x plus 4. And if I solve for y, I end up with 5x plus 4 over x minus 1. So I can just divide by the quantity x minus 1. Now, if we're looking at domain and ranges again, domain, the only thing that I have to avoid here is that x can't be 1. Well, go back and look at your range. Oh, look, I got that I can't have 1 in the range. Now that we swapped x's and y's, that range becomes the domain of the inverse. So negative infinity to negative 1, union 1 to infinity. And my range here, again, I'm looking at my end behavior for my horizontal asymptote. And horizontal asymptote is going to be y equals 5. So that range will skip over, or will have everything except for that 5. And again, look up here. This is your domain. It now becomes the range. I'm skipping over 5. So I've got negative infinity up to 5, union 5 to infinity. Okay, and I'll rewrite this. F inverse of x is equal to 5x plus 4 over x minus 1. Okay. And last but not least, decide if these are inverses. This is what I was talking about in the other video. Okay, we have to check if f of g of x equals x, and if g of f, g of f of x also equals x. So right now I'll start off with f of g of x, which means I'm going to take and I'm going to put the entire function of g in there. So I've got -4 times something plus 2. The something is going to be all of this, -1/4 x minus 2. And right here, if I go ahead and simplify, I'm going to get, I believe, x minus 8 plus 2. And when I simplify, I'm going to get x minus 6. That is not x. So unfortunately, right away, these two are not inverses. If they were, my final simplifying would give me x. Okay, because f of g of x isn't x. Okay, let's check these two. This one's going to be real special. Okay, because we got lots of fractions and we know how much we love fractions. So let's try it. So we're going to get f of g of x equals. Okay, that means I'm going to replace everywhere this is going to be fun, friends. Everywhere I have an x, I'm going to put this entire thing of g to replace it. So right here, I'm going to have 4x plus 3 over 1 minus x minus 3 over 4x plus 3 over 1 minus x, and I have plus 4. Okay, we're going back to first semester. Yay, fractions. Okay, I think the easiest thing would be to maybe just get a common denominator. So I'm just going to focus my attention here and get a common denominator. Focus my attention here, get a common denominator. So my common denominator is going to be 1 minus x. So for this guy, 4x plus 3 over 1 minus x. And then I'm going to have minus 3, and I'm going to multiply by 1 minus x. And this now has the same denominator of 1 minus x. That's the top. All over this second part in the denominator, same common denominator. So 4x plus 3 over 1 minus x plus 4. My common denominator is going to be 1 minus x. I need 1 on the top, 1 on the bottom. Okay. Now, since they both have a common denominator, again, I'm just doing these two fractions. They both have a common denominator of 1 minus x. So now I have 4x plus 3 minus 3, and I believe it's going to be plus 3x, maybe. And here on the bottom, I'm going to have 4x plus 3 plus 4 minus 4x all over 1 minus x. So that's the bottom part. That's this guy right here. So I distributed the 4. Okay. I'm going to go with this guy right here. So up top, these two 3's are gone. So now I have 7x over 1 minus x. And then here, the 4x minus 4x is nothing x. And then I've got 7 over 1 minus x. So now I have two fractions. So keep, change, flip. I'll keep the first fraction, flip the second one, and I'm left with these two, 1 minus x and 1 minus x divide out. So now I have 7x over 7, which is just x. So the first part, f of g of x, equals x. That's a check. Now, here's the fun part, is that we have to go back and do g of f of x to check, does it equal x? I'll start it, but then you have to finish it. So here, g is 4 times x minus 3 over x plus 4 plus 3 over 1 minus x minus 3 over x plus 4. So that's the start of the algebra. Now you've got to decide, how are you finishing it? Do me a favor. When you do this, okay, split these up into two separate problems and then simplify at the end with your fractions. Work on it right now with your group, okay? That is the last of our inverses. What I want you to do after this is I would like you to go back to the warm-up day 1 to finish those problems. Homeworks day 1 and day 2 are what you're doing with these two sets of notes.